In our previous discussions about how stars formed, I mentioned that planets could form around stars. And so planets around other stars actually have two different names that mean the same thing. Extrasolar planets, and that's how I learned it, because this is how they were being referred to at the very beginning, was extrasolar planets. And so I will often use that term because I'm familiar with it. You'll find some books that are written that describe them as extrasolar planets. Another more modern term is exoplanets, which means the same thing. Both of these mean planets around other stars. Exoplanets actually comes from other studies, though, because once you started talking about planets around other stars, you began to realize that maybe some of those could be habitable. And so that raises the whole question is, what would life be like outside the solar system or even outside of Earth? And so biologists have started a study of the conditions necessary for life and the kind of things that life could actually be like. And so they call that exobiology. And so astronomers gradually started adopting how the other sciences name this stuff, and they began calling these exoplanets. I still like extrasolar planets because this is more an astronomical way of naming things because it states exactly what you're talking about. Exoplanets, you have to understand a little bit to know what they're talking about. One of the first to suggest that stars might have their own planets was Giordano Bruno. Bruno lived in the 16th century and was actually burned at the stake in 1600 for saying that the reason that you didn't see parallax was the stars were really far away. Because they're really far away, they must be like suns. And then he went on and said because the Earth goes around the sun and the planets go around the sun, because he believed that Copernicus was right, that meant Earth was a planet. And he went one step further and said, well, that means that if Earth is a planet, the planets are worlds like Earth. And then he said, well, the planets around other stars would be worlds. And then he went one step further and said, oh, wait, if they're like worlds, they must all have people on them. So he assumed that all these planets were inhabited, and then decided that meant that Christ had to come and be crucified on each of the planets to offer everybody salvation, and for that they burned him at the stake for heresy. But one thing that he did have going for him was that he was actually right that Earth is a planet, and that the planets are in fact not just dots or moving stars, that they are in fact worlds like Earth. But the idea that other stars might have planets was kind of revolutionary. We had already talked about how Otto Struve, an American astronomer who studied star formation, thought that the accretion disk around a star would be a great place for planets to form. In fact, he thought that planets were probably very common because they ought to form out of those accretion disks. To that end, he even went so far as to say that he believed that practically every sun-type star had planets around it. Now, it was unclear to him and to many other astronomers about stars that are very, very different from the sun. For example, the really big stars, the really small stars. Really big stars form very, very fast, and so it was unclear if it'd be time for planets to form before the protostar blew away the accretion disk. And really small stars form very, very slowly, and so it would take a really long time for the star to form, which might allow too much stuff to accrete into the star and not enough left to make planets. And so he was more interested in the in-between ones, between the extremes, which would be like the sun. Now, while Otto Struve was pretty convinced that planets ought to form around other stars, for a long time, the only planets we knew were the ones in our own solar system, because finding planets on other stars is hard. He died long before the very first planet was found around any other star. Now, why is this so hard? Well, for one thing, planets are very dim. planets don't shine bright like stars. Stars shine because they're hot. Planets are not as hot. Stars are hot because of the thermonuclear fusion in the core of them. It provides a lot of sustained energy to keep the star hot. That's not the case with planets. Planets typically shine by reflected starlight. Well, planets are vastly smaller than stars, so they only shine with a tiny fraction of the light reflected from the star. Most of the star's light goes off into space. Even dim stars don't have a lot of light, but even bright stars with a lot of light, that light mostly goes off into space and misses all the planets. The planets are a very tiny part of space around the star, and so only a tiny, tiny fraction of the light reflects off of the planet. That makes them very tiny and dim in the telescope. And you have this tiny, dim little speck next to a vastly brighter source of light, the star itself. That makes finding the planets supremely tough. Planets on other stars are so tough that for a long time there was even doubt it could even be done. Even Otto Struve was not completely convinced that we could do that. Well, eventually technology got better, and there turned out to be other ways of finding planets besides just looking for this little speck of light there. The very first planets found around other stars finally occurred in the mid-1990s. Well, that was the first one, 1990s. A planet was found by 1995. Another planet was found around a star. And this was a huge sensation. In fact, the people who found it won the Nobel Prize, not in 1995, but in 2019. So they won the Nobel Prize many years later, but it still was a significant accomplishment. And so they found the very first planet. Just weeks later, another team of astronomers found planets as well, and using a similar technique. And so then other astronomers started finding planets. And so by the end of the 1990s, there were dozens of planets found around other stars. Well, these extrasolar planets, or exoplanets as they are also known as, when I was a student, we called them extrasolar planets, planets on other stars, but the more recent term is exoplanets. And so I typically use these interchangeably. Most textbooks prefer today to call them exoplanets. I learned it as extrasolar, so I typically fall back on that. Technology improved, new ways of finding these planets improved, automated surveys, telescopes looking at different stars on a regular basis, looking for the slight indication of planet are out there operating, finding planets. Even some amateur astronomers have been able to get in on this, studying individual stars, looking for planets. Satellites have been launched just to stare off into space at tens of thousands of stars to see, if there's any planets around them. We'll talk more about this later, but as of summer of 2021, there were almost 5,000 confirmed planets. Now, by confirmed, there's 4771 confirmed planets. What that means is not that an astronomer says, hey, I have found a planet. Confirmed is they announced the discovery of a planet, and subsequent analysis of data or other observations confirm that, yes, there's a planet there. In addition to the 4,700, almost 4,800 planets that have been discovered, there's another almost 3,000 discoveries that astronomers have announced they discovered planets, but they have not yet been confirmed. There's probably another 1,000 or so announcements of planets that have been withdrawn after later analysis shows it's not a planet. So there's been a lot of these things out here that have been announced, but we now know, again, almost 5,000 planets, 4,771 planets on other stars. That is a huge number. And so this actually shows that possibly Otto Struve was right, because only the easy planets can be found. The hard planets we still can't see. The easy to see planets are not going to be necessarily the most common kind of planet. So if this many planets have been found with the technology that we have, which is still being developed, that suggests that there may in fact be vastly more. The technology that exists today would find it extremely difficult, if not impossible, to find a planet the size of the Earth orbiting a star the size of the sun. What we are finding are planets that are easier to find than that. So, in fact, most of the planets in our own solar system would be invisible to the technology that we currently have. And so, again, we're finding the really easy planets. And if there are this many easy to find planets, how many more difficult to find planets are there? And so, Otto Struve was probably right. Most stars actually have planets.